The closed graph theorem. State and prove the closed graph theorem. Statement: if B and B dash are bench spaces and if T is a linear transformation of B into B dash, then T is continuous if and only if graph of T is closed. Proof. Necessary part: let T be a continuous and let Tg be the graph of T, that is Tg equals to x Tx such that x belongs to B is a subset of B cross B dash. We shall prove that Tg bar equals to Tg, and this proves that Tg is closed. Since we know that A is a set is closed if and only if A equals to A bar, where A bar is closure of A, so also A is a subset of A bar is true for all values of A. Since Tg equals to Tg bar closure is true, so we are only to prove that Tg bar closure is subset of Tg. Let xy belongs to Tg bar closure, then xy is a adherent point of Tg. Hence there exists a sequence xn and txn in the Tg that xn and txn tends to xy, which implies that xn tends to x and txn tends to y. But since T is a continuous, so xn tends to x implies txn tends to tx, and so y equals to tx, which shows that xy equals to x tx belongs to Tg, and so Tg bar closure is subset of Tg. Sufficient part: let Tg is closed for any x belongs to V. Define norms of x1 is greater than equal to norms of x plus norms of tx. This is equation 1. Then and norms of x1 is greater than equal to 0 and norms of x1 is equal to 0 implies both ways x equals to 0. Second, norms of x plus y1 equals to norms of x plus y plus norms of t of x plus y equals to norms of x plus y plus norms of tx plus ty is less than equal to norms of x plus norms of tx plus norms of y plus norms of ty is less than equal to norms of x1 plus norms of y1. Third, norms of lambda x1 equals to norms of lambda x plus norms of t lambda x, where lambda is any scalar, so equals to modulus lambda plus modulus lambda into norms of x plus modulus lambda into norms of tx equals to norms of lambda equals to modulus of lambda into norms of x1 implies equation 1 implies defines a norms on B. Let beta B1 denote the linear space renormed by equation 1. Now norms of Tx is less than equal to norms of x1, so that T is continuous and a mapping of B1 into B dash. Therefore, to show that T is a continuous as a mapping of B into B dash, it is sufficient to show that b1 equals to b have a same topology, that is they are homeomorphic. Consider the identity map I equals to b1 to b such that ix equals to x for all values of x belongs to b1. Clearly I is 1 1 on 2. Also norms of ix equals to norms of x is less than equal to norms of x plus norms of tx equals to norms of x, which show that I is bounded and hence continuous. If we now show that b1 is complete, then the theorem let b and b dash be bench spaces and let t be one continuous linear transformation of b into b dash, then t is a homeomorphic in particular t inverse is automatically continuous, will guarantee that I is a homeomorphism, and this will complete the proof. Let xn be a Cauchy sequence in B1, then given epsilon greater than 0 there exists a positive integer n0 such that norms of xn minus xm1 is less than epsilon for all values of n and m greater than equal to n0, which implies norms of xn minus xm equal plus norms of t xn minus xm is less than epsilon for all values of n and m greater than equal to n0, implies norms of xn minus xm plus norms of txn minus norms of txm is less than epsilon for all values of n and m greater than equal to n0, implies norms of xn minus xm is less than epsilon and norms of txn minus txn is less than epsilon for all values of n and m greater than equal to n0, implies xn and txn are Cauchy sequence in B and b dash respectively. Since b and b dash are complete, so we have xn tends to x belongs to b and t xn tends to y belongs to b dash equation 2. Since the graph of t and tg is given to be the closed, so 2 shows that xy belongs to tg, so that y belongs to t of x. Now norms of xn minus x1 equals to xn minus norms of xn minus x plus norms of xn minus x t xn minus x equals to norms of xn minus x plus norms of txn minus tx equal to norms of xn minus x plus norms of txn minus y tends to 0 because xn tends to x and txn tends to y, which shows that the sequence xn is b1 converges to x belongs to b1 and hence b1 is complete.